Welcome to the How-To Factory, the channel where we reveal the secrets behind how your favorite foods, tools, and everyday essentials are made. Today we're talking about something so small yet so powerful, it can start a fire with just a flick. Whether you're lighting a candle, a campfire, or a birthday cake, you're relying on a tiny stick with a chemical tip, the humble match. But how exactly is this little fire starter made? Let's start with a quick history spark. The idea of a portable fire source dates back centuries, but the modern friction match was invented in 1827 by English chemist John Walker. Early matches were clunky and dangerous. Some even exploded or released toxic fumes. But over time, matchmaking became safer, more reliable, and surprisingly high-tech. From chopped wood to precision chemistry, we're heading inside the match factory to show you how these everyday tools come to life. But first, if you're fired up by curiosity, go ahead and like this video, subscribe to the How-To Factory, and hit that notification bell so you never miss a spark of behind-the-scenes action. Modern safety matches rely on two key components, the matchstick itself and the striking surface, and both go through an intense process before they ever end up in your kitchen drawer. It all starts with wood, usually softwoods like aspen or white pine, which are straight-grained and easy to cut. Logs are peeled into long, thin sheets using a rotary veneer lathe, similar to how pencils are made. These sheets are chopped into long matchstick-sized splints and then fed into slicing machines that cut them to length. Next, the matchsticks are dried in huge rotating drums to reduce moisture, ensuring they'll ignite properly. Then they go through a paraffin wax bath, which helps the wood burn more smoothly and evenly once lit. Meanwhile, the magic is happening at the tip, the match head. The key ingredients: potassium chlorate, which provides oxygen, sulfur and fillers which help it burn, and coloring agents, often red iron oxide for that classic reddish tip. Everything is bound together with glue and a bit of starch to keep it sticky. The match head compound is mixed into a paste and then dipped onto the tips of the wooden splints using a carousel system. Rows and rows of upright matchsticks move through the dipping stations and are then dried under warm air until the heads are solid. But here's the safety trick. The match head alone won't ignite with friction. Instead, the striking surface on the matchbox contains red phosphorus, powdered glass, and a bit of glue. When you strike the match, the friction converts the red phosphorus into white phosphorus, which ignites and then sets off the match head. That's why you can't light a safety match without the box. Once dried and checked for quality, the finished matches are bundled into batches, fed into automatic packagers, and neatly inserted into matchboxes, usually by high-speed robotic arms. Each box is printed, cut, folded, and glued with the striking surface applied last. Then, they're shrink-wrapped or boxed up in bulk for distribution to stores around the world. And just like that, something that seems so simple, a box of matches, turns out to be a precise blend of woodworking, chemistry, and automation. The next time you strike a match, remember, behind that tiny flame is a whole world of engineering, craftsmanship, and controlled combustion. Today we're diving into something that's helped shape everything from Renaissance masterpieces to your last DIY project, the paintbrush. Whether it's swiping bold strokes on a canvas or edging a wall with precision, the paintbrush is a tool of art, function, and centuries of evolution. But what actually goes into making the perfect brush? And how do manufacturers make millions of them, each designed to glide, hold paint, and keep its shape stroke after stroke? Stick around, because we're going inside the factory to see how raw fibers and wooden handles come together to form one of the most widely used tools in human history. Now let's rewind. The earliest paintbrushes date back over 30,000 years. Ancient brushes were made from twigs, animal hair, even feathers. By the time of the Renaissance, brush making had become a true craft, using hog bristles or squirrel hair, hand-plucked and tied into wooden handles. Artists were very particular about what fibers they used, and not much has changed. And before we dip into the details, give this video a quick like, subscribe to the How-To Factory, and hit that notification bell so you never miss a behind-the-scenes look at how the everyday becomes extraordinary. Today, while synthetic materials have taken over much of the market, the brush-making process is still a combination of precision, craftsmanship, and chemistry. It all starts with the bristles, and there are two main categories: natural and synthetic. Natural bristles usually come from hogs, prized for their stiff split ends that hold paint well. These are used mostly for oil-based paints. Synthetic bristles, made from nylon or polyester, are more versatile, often used with water-based paints, and easier to clean. Bristles arrive at the factory in long bundles and are first combed, aligned, and trimmed to size. Some high-end brushes feature a taper, meaning the bristles are thinner toward the tip, allowing for more precise strokes and better control. This tapering is achieved either by selecting naturally tapered hairs or by mechanically tapering synthetic fibers. Next, the brush head is formed. Workers gather a measured amount of bristles, called a ferrule charge, and press them into a metal casing called a ferrule. The ferrule is typically made of nickel-plated steel or aluminum, crimped tightly to hold the bristles in place. But it's not just a mechanical squeeze. A special epoxy resin is added at the base of the bristles to lock them in and prevent shedding. This step is key. No one wants brush hairs stuck in their fresh paint. Now it's time for the handle. Handles are usually made of wood or plastic. Wooden handles, often made from beech or birch, are cut, shaped, sanded, and then dipped in varnish or painted for durability and aesthetics. Some even have rubberized grips for comfort. Once the ferrule and bristle bundle are ready, they're attached to the handle, typically with industrial-grade adhesive and mechanical crimping to make sure they never come loose. After assembly, the brush is shaped and trimmed again, giving it its final form, whether flat, angled, or round. Then, it's quality control time. Each brush is tested for shedding, stiffness, and shape retention. High-end brush lines often involve more hand finishing and inspection to guarantee performance. Finally, the finished brushes are tagged, packaged, and boxed, ready to be shipped to hardware stores, art supply shops, or directly to your garage. So the next time you pick up a paintbrush, whether you're outlining trim or painting a mural, you'll know it took carefully engineered fibers, perfectly balanced parts, and a factory full of craftsmanship to get it into your hand.